In this video, we will get you fully up to speed from scratch with the whole idea of sets and Venn diagrams, and we'll even choose some pizza. If you're already familiar with Venn diagrams, or you just want a quick reminder as part of your revision, then do go and check out our quick recap video, which summarises the material in a blast. I'm Ben, and today we'll be going nice and steady, learning about Venn diagrams with some simple puzzles. Almost too simple, and we'll pick up all the fancy pants mathemachicken language along the way. About halfway through, we will need to choose some pizza, and if you stick around to the end, I'll tell you about an easy way to download and remember all of the fancy pants stuff that we learned today. So let's get started. Okay, clear your minds, everyone, close your eyes, and think of a beautiful beach. And on that wonderful white sand, you have a huge rectangular beach towel with a lovely picture of the stars, the galaxy, and the universe on it. Does it look a little bit like this? Probably not, but there's a reason I've got this here. Get ready, I'm about to say puzzle 6 times. This universe beach towel represents our puzzle board, and that's all Venn diagrams are. They're just a puzzle. And this beach towel is where we're going to do those puzzles. The towel is our puzzle board. It's our universe. But in order to do a puzzle, we'll first need some puzzle pieces. So here they are. We have a goldfish, a moon, an angry potato, a carrot, a chicken, a feather boa big enough to go around Jupiter, a feather duster, and a baby elephant. Let's put these pieces onto the universe puzzle board. Now, you might be thinking,
why does he keep saying all this stuff about the universe?
Well, getting an intense visual picture in your head, in this case of a universe beach towel, is a strong mental hook. It will help you remember that in the world of Venn diagrams, this towel rectangle represents our universe of stuff. And so we are not interested in anything unless it's in this rectangle. This rectangle always exists, so never draw a Venn diagram without the towel. So the entire collection of stuff on our towel is known as the universal set. A set is just a collection of things, or a collection of elements. And in this case, it's all the 8 puzzle pieces you can see here contained within the rectangle. There's even a fancy pants symbol for this universal set that you'll see in many question papers and may need to write it yourself. Here it is, have a go. It's not very memorable, so whenever you come across a boring situation like this during your studies, try and come up with a mental hook which will help you remember. And the sillier the better. In this case, to me, the symbol looks like a 3 which has been flicked around and then has a squiggle at the bottom. So I might use something like, it's a backwards 3 with a tail, you see. It might sound daft, and that's because it is, but it really helps to make it stick when otherwise it would be dry and boring. So, it's a backwards 3 with a tail, you see. Just make sure you don't sing it out loud during the exam. The universe symbol is written next to the rectangle, so we know that the rectangle represents the universal set. Right, we will move on to our first puzzle, but very quickly, one more bit of fancy pants language. We know that this symbol is our universal set, to represent all our pieces. But what if we wanted to say or ask, how many objects are there in the universal set? Well, the way we do that is by using an N and a pair of brackets. It just means, what is the number of things, N for number, in whatever set I put in these brackets. So for our towel, or universal set, we would write this. And by counting, we know that we have 8 objects in the universe. Very simple. So, how many things in the universal set is this? How many things in a deck of cards, if you don't count the jokers, is this? And how many jobs are on my to-do list is this? Right, that's enough of the fancy pants stuff. Let's get on with a puzzle. Let's get rid of the universe picture and just keep the rectangle outline and the same 8 pieces. Now imagine you have a big hula hoop on the beach towel. There we go. I'll call it H for hoop. So the first challenge is, can we move our pieces so that in H we have only orange things. Well, this is obviously straightforward, so let me jump straight in. The goldfish, that's orange, so that goes in. The moon, no, that's grey. Potato, not orange, outside the hoop. Carrot, orange, in the hoop. Chicken, not orange. Feather boa, big enough to go around Jupiter, orange. Feather duster stays outside. Baby elephant, not orange. So that was very, very simple. But what we've created here is a collection of objects within hoop H. We have these three elements, the fish, the carrot, and the boa. Remember, we said the collection of objects on the towel was the universal set. Well, now we have a collection of objects in a hula hoop. So this is also a set and is known simply as set H because that's what we called it. We could have called it anything. So now we have a set for the universe and a set called H for the elements in the hoop. And remember, we could show the number of items in the universal set like this. So what do you think this represents? Well, yeah, it simply means the number of items in set H, the collection inside our hula hoop, which we've got three objects. Make sense? So let's write down what we have in H. We have the fish, the carrot, and the feather boa big enough to go around Jupiter. Now, that looks like quite a casual, informal way to write down what we have in our hula hoop. The formal, fancy pants way to write it down is known as set notation. And guess what? It's very, very easy. All you have to do is put curly brackets around your stuff. It's honestly as simple as that, although it's quite difficult to draw curly brackets. So this is set notation, and this, curly bracket, is also set notation. Absolutely nothing to worry about. Just make sure you add your curly brackets in all your questions to avoid losing any marks in exams. Okay, let's quickly change our challenge. And let's say the rule for set H has now changed so that we need things that have feathers in the hoop. And why not use formal notation? So, sure, you can all do this. It's simply fish, no feathers, moon, no feathers, potato, that's got feathers, yes, and there we go. Again, so we've got our set of objects in H, which is this shaded area here. So if we step back, what do we know about the items in this set? Well, I might just be stating the obvious, because I am, but the things in this set have feathers. Very straightforward. But what can we say about any items that are not in the hoop set? So items that are in this area. Well, these objects are outside set H, and so what we can say about these is that they do not have feathers, which may sound obvious, but it's not always made clear. So remember, wherever an object is positioned on the towel, you should be able to say something factual about it. So things inside the set have the property, but things outside the set do not have the property. Let's do a quick scribble. If we look at this first diagram, we can shade the area for set H. And in this second diagram, we'll shade the area for things not in H. So this area is not H. One thing to notice is that if we add these two shaded areas together, like a pair of jigsaw pieces, what do we get? Well, we get a perfect rectangle which fills the whole towel, which is the full universal set. We know the universal set symbol is this, and we know our hoop area is shown as this. But what do we call this area, other than just not H? Well, this area is actually called the complement of H. And we symbolise this with a little apostrophe or stick here next to the letter. So H stick. I prefer thinking of H stick because it helps it stick in my head. And if you have trouble remembering the name complement, try and think of these two jigsaw pieces as being a good complement for one another because they fit together perfectly to make the universe. Remember, at the end of this video, I'll give you an easy way to download and remember all of this fancy pants stuff. But we can see now that H plus H stick equals the universe. And you could even use this for the number of items involved. So the number of things in H plus the number of things not in H, so in H stick, equals the number of things in the universe. And very simply, you can see that is 3 plus 5 equals 8. So just remember, H is inside the hoop and H stick is outside the hoop. It's as simple as that. Time for you to have a go at a puzzle. So this time, let's start with 2 hoops on our towel. We'll call them A and B. The rules for this puzzle are, in set A, I want all the grey things, and in set B, let's have all the things that have got eyes. So, now that we're getting a bit trickier, I'd like you to try this one for yourself. Pause the video, see if you can work out where things go, and I'll see you shortly. So pause now. Okay, I confess I was a little bit of a meanie to you there. Let's see why by going through these objects. Okay, so the goldfish first. That is not grey, not in there. Does it have eyes? Yes, let's leave it there. The moon, grey? Yes, put it in A. Potato, not grey. Does it have eyes? Yes, goes in B. Carrot, grey? No. Has eyes? No. Can leave that one on the towel. Chicken, not grey. Does it have eyes? Yes. Boom, in B. Feather boa big enough to go around Jupiter. And I'm getting tired of saying that, so I'm just going to call that Fabetgaj from now on. That is not grey, and it does not have eyes, so it doesn't go in either. And the feather duster is neither grey, nor does it have eyes. Now, baby elephant. Aha, and this is the one where I need to apologise. Sorry if you tried it yourself and got a little stuck on this chappie. So we can see here we've got a baby elephant that's grey, so it needs to be in set A in this hoop. But actually, it's also got eyes, so it also needs to be in set B hoop too. So how can it be in both places at once? Well, if you've seen a Venn diagram before, you'll probably already realise that we need to overlap our hoops to enable this. So let's do that and tidy up a bit. So in this setup, when it comes to our baby elephant, who is grey and has eyes, there is a perfect little area here that is in set A for its grey property and set B for the fact that it has eyes. So we have satisfied the puzzle. The elephant is sitting in set A and set B. If we draw that little area in a diagram, we can see that it's this overlapping or intersecting bit that represents being in set A and set B, or is grey and has eyes. In Fancy Pants Mathemachicken language, this intersecting bit is actually just called the intersection. And is there a Fancy Pants symbol for this intersection between two sets? Well, of course there is. In fact, we've actually already drawn it. It's here, and looks like an upside down U. So whenever you need something to be in two sets at once, like A and B, or orange and feathers, think of the word and, written like this, to remember the symbol for intersection. To help you understand these intersection areas when you're faced with a tricky question, try to think about having some coloured see-through plastic, like the stuff you sometimes get as sweet wrappers. If I used a circle of coloured plastic for set A, and then a second circle of plastic for set B, we can quickly see that where they overlap and intersect, the area is darker because there are two layers of colour. This area is our intersection for A and B. Hopefully that makes sense. And this works in more complicated examples too. Let's say the question asked about the area that represents things that are grey and do not have eyes. First, how would we write this out in Fancy Pants language? Well, first off, we've got things that are grey. Well, this is just our set A, that's easy enough. And then let's actually draw the area for this below. Then it's and something. So we need to use our intersection symbol. And finally, we want things that do not have eyes. If they wanted things with eyes, would be easy because that's just set B. But because the question does not want eyes, they want things that are not in B. And remember the symbol for this from a few minutes ago? It's B stick, or the complement of B. Let's draw the area for this below to represent the complement of B, or B stick, which is everything outside B. Now, if we look at these two areas as bits of plastic on the same diagram, we can see where the dark intersection is. This area is the complement of B, and this area is A. And so you can see here's the dark intersection where the coloured plastic overlaps. If ever you want to use this method in real life, you obviously won't have coloured plastic in an exam, but what you can do is shade one area in with lines sloping in one direction, and then shade your second area with lines sloping in a different direction. And then you will see that the intersection is the area which has got crisscrossing lines in it. Right, I think that lots of you will now be getting the hang of this, so we'll have a quick pause to give you the pizza challenge. But first, it might interest you to know that as well as this maths channel, I actually have a second job in a pizza shop. To be honest, I need the dough. Okay, on to the challenge. You have been given a plain cheese and tomato pizza. You have a choice of up to 3 extra toppings. What are you putting on that bad boy? Here's the question in Venn diagram format. All I want you to do is decide which area you would put yourself in and let us all know by typing in a number from 1 to 9 in the comments below. If you're feeling brave after your number, write what toppings you're having so we can check whether you've understood Venn diagrams. And if any of you manage to get an intersection symbol in there, I will be extremely impressed because I've got no idea what font you'll have used. Okay, pause the video now to make your pizza choice, like and subscribe, and then we'll finish off the final piece of core Venn diagram knowledge. Welcome back. I look forward to reading the comments and seeing what you've chosen. Maybe we can analyse all of your choices in a future video on data and probability. Right, let's tear our minds away from pizza back to Venn diagrams. Here's a diagram with 3 different sets. So our 3 sets can be A for orange things, B for things bigger than a baby elephant, and F for things with feathers. Have a pause and see if you can work out where everything goes. Right, let's have a go at this one. So when tackling something a bit more complicated like this, it's good to take each object in turn and then cycle through the different sets to narrow down the area where that object needs to go. Let me show you what I mean. So let's start with the goldfish. If I circle round the A, goldfish, is it orange? Yes, so we know we're going to be in this circle. Let's go on to B. Is it bigger than a baby elephant? No, it's not. So it's not going to be in that little area. So we're going to be in this sort of crescent-shaped area. Now on to feathers. Does it have feathers or not? No, so we need to be outside the feather circle. So that puts it in this section. Same with the moon. Is it orange? No, so we're not in this circle. We need to be somewhere else. Let's go on to the next one. Is it bigger than a baby elephant? Yes. So we are in this circle, but remembering that we're not in the orange circle. So in a crescent again. Has it got feathers? No. So we ignore the feathers bit, and we are in this section. Same again. Let's go with this potato. Not orange, not bigger than a baby elephant, not got feathers, not in any circle, one of the easiest. Carrot, orange. We're already knowing that we are in this circle. Is it bigger than an elephant? No. Has it got feathers? No. Same as the goldfish. Chicken, orange? No. Bigger than a baby elephant? No. So it's outside those 2 circles. Has it got feathers? Yes. So we're in this feather circle, but avoiding the orange and the bigger than an elephant circle. The Fabetgaj, is it orange? It is in this circle. Bigger than a baby elephant? Of course it is. It's big enough to go around Jupiter. So it's in both of those circles. So we know that we're in this intersection area now between these 2 circles. Finally, does it have feathers? Yes, it does. So it's also in the feather circle. So this one is slap bang in the middle because it's got all 3 properties. Feather duster, not orange, not big, but it has got feathers. So that goes with the chicken. And finally, baby elephant, not orange. Is it bigger than a baby elephant? Well, this is important when it comes to inequalities. Is it strictly bigger, the question's asking, or is it as big as, at least as big as? And we can see from the question it's bigger than. So a baby elephant is not bigger than a baby elephant, it's as big as a baby elephant. So that's the difference between strictly greater than and greater than or equals to. So it doesn't belong in the bigger than a baby elephant circle, and it doesn't belong in the feathers circle. So there we go. Did you get the same as me? Let me know if I've made a mistake. Right, we've got one more concept to cover. We've already covered and. For instance, if it's orange and has feathers, we've got this intersection here. But what if we had or? And let's use our way of spelling or. So now the question becomes, show the area which contains objects that are orange or have eyes. Sounds easy enough. This is the area for orange things, and this is the area that has eyes. But now we've just got the same shaded pattern as we had before with this dark intersection, and that's perfectly fine. But because our question is now about or, we don't just have to look at the dark area, because just being orange or just having eyes is now also acceptable. This means we want all of the shaded area, whether it's light or dark. And that's because things that are orange or have eyes will always appear somewhere where it's shaded, whether light or dark. Things that are orange and have eyes will always appear in the darkest area. And so there must be a fancy pants symbol and word for these or questions, mustn't there? Well, of course there is, which is why we had our way of writing or. This will help you remember that the symbol for or is this. Looks like a capital U. The fact that it looks like a capital U should also help you remember that the fancy pants word for this is union. So remember, with and we have this symbol for the intersection, and with our way of spelling or, we have this symbol for the union. Okay, we've covered the Venn diagram basics. Well done. I really hope you're getting the hang of these puzzles now and are feeling a lot more confident. Quick newsflash though, I hate to break it to you, but real exam questions probably won't have pictures of baby elephants or Fabet gadgets. You'll probably get something a little bit more boring like this example. Feel free to have a go at this and stick your answers to number 2 in particular in the comments. Or watch my question practice video in which I walk through other Venn diagram example questions in much more detail. Thanks so much for watching. If you found this useful, please give me a thumbs up or even subscribe so you don't miss other videos. Now, I promised that I would give you an easy way to download and remember all of the fancy pants mathmachicken stuff, didn't I? Well, pleased to say that I've created a series of flashcards to summarise all of the key information from this video, using the same language and all the same memory hooks. The print files are laid out easily so that you can simply fold them over and have the answers on the reverse. And you'll be able to build up your collection of flashcards throughout all my videos. I hope you find them useful. They're completely free, so go get them. The link is in the description. And do go and check out our other videos, including how probability is used with Venn diagrams. So for now, that was Venns with Ben. Until next time, I'll see thee.